So yesterday we completed solving one-step equations, and today we are going to solve two-step equations. And so if we were going to say an I can statement, by the end of the lesson you should confidently be able to say I can solve two-step equations for a variable. And so if we look at this first problem way up on the top, it says solve for m over 5 equals 12. And this is what we did yesterday. So we saw a division, and so we knew that its inverse was multiplication. So we were going to multiply by 5 to both sides, and we were going to get m equals 60. And that's totally awesome. But today we are going to do multiple steps rather than just that one. And so when we have more than one step, we need to go back and recall the order of operations. And luckily we just covered it, so we all know the order of operations. And it's parentheses, exponents, multiplication, division, addition, and subtraction, or PEMDAS, or please excuse my dear Aunt Sally. However you remember it, it's totally fine. And when we solve for a variable, though, we need to start on the side with the variable. And so start on the side with the variable, and then you want to undo the operations. And here's where it's really important. You work in the reverse order of PEMDAS, or the reverse order of the order of operations. And so if I was you, I would be highlighting this in Notability or on the paper in front of you, because that's really important that we work backwards. So when we work with the order of operations, we always want parentheses, exponents, and so on. And now that we're solving, we're actually going to start here with addition and subtraction. These are kind of grouped. And then we're going to work backwards towards those parentheses. And remember, not only are addition and subtraction grouped, but so are division and multiplication. They're also grouped. Then parentheses and exponents are kind of on their own. But we're going to work backwards, and that's what's really important to remember. And not only that, but like always, when we are solving, we want to isolate the variable. And you're going to hear me say this over and over throughout all year in algebra, because I love the word isolate. Isolate the variable. Get the variable alone when you solve, because that is what we need to figure out. Get the variable alone. Moving forward, some helpful hints. Always start on the side with the variable, which we've already talked about. Undo operations in the opposite order of PEMDAS. So you're actually going to start over by the S and work your way backwards. Remember that. If you do it to one side, you must do it to both sides. And I can't stress enough, always check your answers. Check your answers, check your answers, check your answers. Because sometimes it may not work, and then you know if something went wrong or it's a special case. So to begin, our first example is solve an equation using division and addition. And so they tell us what operations we're going to use, because I see multiplication right here, and then I see subtraction. And so if we look over at our goal is to isolate variable. Remember, we're always isolating. And so if we think about the order of operations, remember we work backwards. So rather than starting by undoing the parentheses, we are going to ask ourselves, do we have any subtraction to undo? And yes, we do. So we're going to undo subtraction first, and we're going to use its inverse of addition. So I'm going to add 3 to both sides. And I'm left with 2x equals 18. Next, do I have any addition? No. Do I have any division? No. Do I have multiplication? Yes. So I'm going to undo that multiplication second, and I'm going to use its inverse of division. So divide both sides by 2. I am left with x equals 9. However, like I stressed before, substitute it back in to check your answer. 2 times 9 minus 3 equals 15. 2 times 9 is 18 minus 3. Yes, it is 15. And I am good to go. So now if we get PEMDAS ready to go again, solve the equation 5y plus 12 equals negative 13. Notice we have multiplication, we have addition. So I asked myself, do I have subtraction? No. Do I have addition? Yes. Undo addition, because remember you always start over on this side undoing. So I'm going to minus 12 to undo that addition. And I'm left with 5y equals, here we have something for you guys to know, negative 13 minus 12. Subtracting a number is the same as adding a negative, so we can say negative 13 plus negative 12. This gives us negative 25. Next, do we have division? No. Do I have multiplication? Yes. So I'm going to divide by that 5 to both sides. And I'm going to be left with y equals negative 5. Notice if only one is negative, it's going to stay negative when you divide. So I have my answer, and now I need to check. 5 times negative 5 plus 12. Negative 25 plus 12. Yes, it is negative 13. Now we have 4 examples for you to try on your own. So go ahead, pause the video, give them a try, come back to check your answers. Going over these problems, problem number 1, your answer is b equals negative 2. Problem number 2, the answer is x equals negative 1. Number 3, you should have got c equals negative 3. And problem number 4, now that's a fraction, but that's okay. K equals negative 11 halves. If you did not get these answers, go ahead and try again, or ask tomorrow in class how to solve. Moving forward, our next example is x divided by 4 minus 7 equals negative 2. And on top, I'm going to just make a note of PEMDAS again, so that I remember that I'm going to start over by the s and work my way backwards. And my goal, like always, is to isolate the variable. But first we need to figure out what we're going to undo. So I asked myself, do I have subtraction? And yes, I do. It's right there. So because I have subtraction, I'm going to undo that first, and I'm going to do its inverse, which is adding. So add 7 to both sides. X over 4 equals 5. My last thing is that division. I'm going to undo it with multiplication. Multiply both sides by 4. X equals 20. And finally, we need to substitute in and check our answers. So is 20 divided by 4 minus 7 equal to negative 2? 20 divided by 4 is 5. 5 minus 7 is negative 2. So yes, it is good. We are correct. And next we have 5 plus y divided by 2 equals 18. So going back to this PEMDAS, do I have any subtraction? Well, no, so I'm not going to undo it. Next, do I have any addition? And yes, I have addition right there. Now here's where it gets tricky. We want to move things, but we don't want to move the thing with the variable. And so what we really were looking at is we need to get rid of this 5, but we have to ask ourselves, what is our symbol here? And really, it's a positive 5, so it's kind of like addition. And to undo it, we are still going to subtract. But notice, I subtracted my 5 and not the item with my variable, because you don't want to move your variable if you don't have to. And so when I subtract 5, I get y divided by 2 equals 13. Continuing forward, I need to undo that division, so I'm going to multiply by 2 to both sides, and I end up with y equals 26. And like always, we need to double check that answer. Is 5 plus 26 divided by 2 equal to 18? Well, we have 5 plus 13. Yes, that is 18. So it's our final answer. So notice, we don't move the item with our variable if we don't have to. Always move the other stuff on that side. Just like the last practice problems, go ahead, pause the video, solve them on your own, and come back to check for the answers. And our answers for problem number 1 is A equals negative 12. Number 2, our answer is x equals 72. Number 3, h equals 9. And in number 4, we get a equals 40. These are great problems to ask about tomorrow in class if for some reason your answer doesn't match mine. Also, go ahead and try them again now that you know the answer. Next, we're going to solve an equation with 2 terms in the numerator. And so here, what we need to do is we need to get x out of being a fraction. So we have x minus 7 divided by 3 equals 12. And typically, we would be like, oh, we need to undo subtraction. But we can't undo that until it's no longer a fraction. So when you see something like that, you're actually going to get rid of this 3 first. So we need to undo our division first in this case. And to do that, we are going to multiply by 3. So don't let this confuse you. And when we do that, the beauty is we are now x minus 7 equals 12 times 3. And if we do the math, 12 times 3 is 36. And now notice this x is no longer in a numerator. It's no longer part of a fraction at all. It's standing alone by itself. And that means then we can go ahead and keep solving how we traditionally would. So I see minus 7. I know to add 7. And I end up with x equals 43. And that would be my final answer. So notice we had to take it out of the fraction before we could work with it. However, like always, I need to double check. Is 43 minus 7 divided by 3 equal to 12? That's what I'm asking. 43 minus 7 is 36. 36 divided by 3, yes, it does equal 12. So that is my final answer. Notice the difference here compared to what we did earlier. Once again, we're back to try it on your own. Pause the video, give them a try, come back and check for the right answer. And now that you hopefully worked it out, if we look at problem number 1, when we solve, remember we are going to get rid of this denominator first, and in doing so you should end up with z equals 8. Same thing with problem number 2, we need to get rid of this denominator, get rid of that 7, and you should end up with d equals negative 7. If your answers vary, do the same as before. Try again, ask tomorrow.